Okay, so number 11, use the graph to find the domain and range, the intercepts, the horizontal asymptotes, vertical asymptotes, oblique. So based on this graph, the domain is going to be everything except for where the vertical asymptotes are, which are at -3 and +3. So you should be able to put plus and minus 3. If you put x equal -3, x equal +3, that's okay too. The main thing is look at your vertical asymptote for that. And for the range, you're basically looking for where all the y values are defined. So it's everything except for the -2 to start with. So below -2. And it's also from this point up, so that's y greater than or equal to -1. So below the -2, but not including it, and then above or equal to the -1, because it's not defined in the little spot between the -1 and the -2. For your x-intercepts, they're right there, which are 2 and -2. So we can put plus and minus 2. For the y-intercept, it wants to the integer, and we said that was at -1. So put -1 there, because it's based on 0, -1. Then the horizontal was at -2. The vertical at plus and minus 3. And in this case, there's no oblique asymptote because it's nothing tilted. You're right. Yeah, if there's a horizontal, there's not an oblique. Oblique would be tilted up or down like that. So if it has a horizontal, then it won't have an oblique. So this is going to be no oblique. Okay, the next one, we're going to DMS form, and it's 46.703 degrees. So you know you're on the right track if you start with 46 degrees. Okay, and this one, make sure you're in degree mode. Make sure you're in degree mode. At the moment, I'm in radian mode, so I just single click up here, like that. And we put 46.703. Then we hit the open book and go to DMS from 1. That tells you this answer. Now the 10.8 was the last thing that was on there, but it says round to the nearest second, and so you need to put 11 there. Make sure y'all put that, because I saw some people miss that on the test, and that's a minor thing. It says round to the second. So make sure you get that. The other way to do it without using the DMS from the catalog is if you do your 0.703 times 60, you get 42.18. So then you take your 42 and put it there, and then you do your 0.18 times 60, you get 10.8. You round it and you make your 11 right there. So that's how you do it by hand if you don't want to use the catalog. And remember that your answers should be reasonable. If you were in radian mode and did this exact same thing, whoops, I need to click one more time. If you're in radian mode, did this exact same thing, you get 2,675 degrees, which is not reasonable because it's 46. All right. Here you want your composite function. So for f circle G, you need your domain of G also. Your domain of f would be all reals x naught 2, and your domain of G would be all reals x naught 0. Just from looking where the denominator could not be 0. Okay, then we're doing f circle G, so that means start writing the f function. So 7 over something minus 2, and then put the 5 over x there. Now, what you need to do is get a common denominator for here, and to do that, what you're going to do is multiply by x over x. Yeah, in the bottom only, right. So we have 7 over 5 minus 2x over x. Then act like it's 7 over 1, and then multiply your outsides, and that goes on top. Multiply your insides, and that goes on bottom. So that's your equation. They just want the domain. So we need to set our denominator equal to 0. Get 5 equal 2x, and then divide by 2, so you get 5 halves. So the domain would be everything except for 5 halves, as well as the domain of G, which in this case is 0. So make sure you put x naught 5 halves and x naught 0.
Does it matter which one goes first?
No. Good question. So x naught 5 halves and x naught 0. Alright, the next one says use the rational zeros theorem to list the potential rational zeros. Do not attempt to find them. In other words, don't just graph it and try to find which ones, because these are going to all be more than what you need. These are all the potential ones. So the two variables we used for this, besides the x, are the q and the p. The q is what's in front of everything, and so in this case it's 1. And the p is the back, which is negative 17. Yes, and it's p over q. So for the negative 17 for p, you can make a chart or tree, and it's positive 1 times negative 17, or negative 1 times positive 17. So what that means is it's plus and minus 1 and plus and minus 17. Those are your 4 for P. For Q, we have positive 1, and so you could think 1 times 1 or negative 1 times negative 1. So it's basically plus and minus 1. Now that we have our possible values for P and Q, we need to do P over Q. And so that's going to be plus and minus 1 over 1. And plus and minus 17 over 1. Yeah, so that's A. All right, so there's 14 questions. Okay, for 15, you're doing all these different combinations. So for x squared plus 5, what that graph looks like is it's a parabola that's shifted up 5 units. So it looks like that. So that particular domain would be all reals because there's no limitations. The G domain would be x greater than or equal to 1. The graph of a square root function usually includes this unless there's something really weird with the function. So it's not just x greater than 1, it's x greater than or equal to. Because if you do 1 minus 1, you get 0, and you can do the square root of 0 because that's 0. So if you have your x minus 1, that's going to shift right 1, and then your graph is going to look like that. Okay, we're going to refer to these parts as we do all our domains. So for your function itself, we're doing f circle g. That means you start writing your f function. So something squared plus 5, and then put this here. So the square root of something squared cancels, so you get x minus 1 plus 5. So that's x plus 4. This part is your answer. Now for that x plus 4, you know that's linear and it's up 4. So it looks like this. That domain is all reals. When we're doing f circle g, we need the f circle g, which is all reals, and we need the G domain, which is x greater than or equal to 1. So we have to put that x greater than or equal to 1 because of this part. Because if it's not defined for the original, it won't be defined for the combined. That's the reason. Okay, so the next part we have to do G circle F, and so this one we're going to need the domain of G circle F and the domain of F. The domain of F we said is all reals, and so there won't be any extra limitations. We'll just have to get it. So the G circle F looks like the square root of something minus 1. Because you basically start writing your G function, and then you plug this in for x. So you get x squared plus 5. So what you do for that is get x squared plus 4. Because it's a square root and it has a plus sign, you cannot split it up. It's not the same thing as the square root of x squared plus the square root of 4, which is x plus 2. That's not right at all. You can't do it that way. If you were to graph x plus 2 and the square root of x squared plus 4, they don't look alike at all. This one's linear, this is a square root. So keep it this way, and that's your answer. Square root of x squared plus 4. You can't do it like square root of x squared plus square root of 4. You can't split them up. Yeah, you're not allowed to do that. Just like if you have a fraction like 1 over x plus 4, that's not the same thing as 1 over x plus 1 over 4. Those are breaking algebra rules. You can't do it that way. What you can do is if it were like x plus 4 over 2, on top you can break it where it's x over 2, which is really a half x, plus 4 over 2, which is 2. So you can break it this way, but you can't break a denominator and you can't break a square root. Okay, good. Alright, so we have the square root of x squared plus 4. What we want to do is graph that. The square root of x squared plus 4 looks like that. It kind of looks like a parabola. There's no vertical asymptotes, so this would be all real numbers. So for the G circle F, it's all real numbers. And for the F, it was all real numbers. And so it's going to be the one that's choice B with all real numbers. Any questions? Okay, then for F circle F, start writing the F function, which is something squared plus 5, and then put your x squared plus 5 here also. Then you need to expand that using FOIL or using your shortcut. X squared squared is x to the 4th. And then you've got x squared times 5, which is 5x squared, and you got to double it. So you get 10x squared. And then 5 squared would be 25, and then you're adding 5. That gives you x to the 4th plus 10x squared plus 30. X to the 4th plus 10x squared plus 30. Now, as far as your domain of F circle F, your domain for the x to the 4th function would be all reals. And your original F domain was all reals also. And so you get the B answer, which is all reals. Now we're going to do the G circle G. So we start writing the G function. Whoops. Okay. Start writing the G function, which is the square root of something minus 1, and then plug in the x minus 1 here. That's going to be your answer. It's a square root underneath another square root. Yeah, it is messy. It's not the same thing as x minus 1 to the 1/4 minus 1, and it's also not the 4th root of x minus 1 minus 1. Again, like we said earlier, you can't break it up. Cannot break it up. And so the square root, x minus 1 minus 1. Now, to get the domain, the easiest way is probably graph it, but if you'd rather plug in certain points and see what happens, you can. Like if you plug in a 1, 1 minus 1 is 0, so this part's satisfied, but then you'd have the square root of 0 minus 1, which is negative 1, underneath the square root, so that's imaginary. All that to say, 1 would not be valid for the domain. 2 will be, because if we do 2 minus 1, we get 1, and then we do the square root of 1 minus 1, which is 0. So what you're going to want is x greater than or equal to 2. Another way to do it, besides just plugging in, trying numbers, is to graph it. So we've got the square root of a square root, x minus 1, and then move minus 1 out here. And that's where the 2, 0 is. Remember, you can do Control T to get to your table, and 2, 0 exists. Now, the thing that's a bit tricky about this one is that was our G circle G domain. We also need our G domain, which was x greater than or equal to 1, but the x greater than or equal to 2 restricts more. Yes, exactly. X greater than or equal to 2 restricts more. In other words, it can't be 1, it has to be 2 or bigger. And so that's going to be what you want. Yes, it will. Yeah. Any other questions about that? Okay, number 16, solve the equation log base 3 of 9 equal 4x plus 4. What you do for this is take this 3, which is a base, move it over here, and push this up. So you get 9 equal 3 to the 4x plus 4. Now 9 is to the first power, but you can't set those equal because you don't have a common base. You've got to change 9 to be 3 squared. Once you get your common base, then they can cancel, so to speak. So you get 2 equal 4x plus 4. Then subtract 4. And you end up with negative a half. The solution set is just negative a half. You don't put x equal negative a half. It says integer or fraction. So in this case, it's a fraction. The other way to do it, if you really needed to do it this way, is like this. Graph it and make your left side log base 3 of 9. So I do control 10 to the x. So there's your log. You're able to type in your base and your 9. Now that's just a horizontal line because there's no variable involved for the left side. And then the right side is 4x plus 4. And you want to see where they cross. So basically go to Menu, Analyze, Intersect between here and here. It's negative 0.5 comma 2, and you only take your x value, and the negative 0.5 has to change to a negative a half because it's a fraction, not a decimal. Any questions about that? Okay, on this one you want a positive angle that's less than 2 pi. So my hint for this would be take 2 pi times 6 to get 12 pi. What that means is you need less than 12 pi over 6 because that's less than 2 pi. So do that first. From there, do your 35 over 6 minus 2 repeatedly until you're smaller than 12. So 35 over 6 minus 2 gives you 23 over 6. And then you subtract 2 again, and you get 11 over 6. Well, it's in terms of pi, and so whenever it's in terms of pi, you would either do plus or minus 2 pi, but it's already too big, and you want one smaller because it says less than 2 pi. So I'm basically subtracting 2 pi repeatedly, but on our calculator what we do is just use the 2. So we go 35 over 6 minus 2. That gives you 23/6, and then subtract 2 again, we get 11/6. So now that we have something smaller than 12, we've got to just put your 11 pi over 6. You need it less than 2 pi, and your denominator is 6, and so 2 pi times 6 would be 12 pi. So if you had a 5 here, 2 pi times 5 would be 10. You need it to be smaller than 10. Yeah, so just think of it as what's coterminal with 35 pi over 6. Any other questions about that? All right. Then on this one, for the following, find the real zeros, use the real zeros to factor. So your first step you know to do is to graph it. And I want you to remember a root is the same thing as a real zero. Root is the same thing as a real zero. So the first step is to do your graph 71x up arrow 3. Not 71, just 7. 7x to the third minus 71x squared plus 185x minus 25. Okay, so there are going to be two. You need to remember the thing about the multiplicity. Whoops. Multiplicity. So about that, it's even if it touches, and it's odd if it crosses. And so we're going to have one place where it crosses and the other place where it touches. All right. Now, this thing that's a little to the right of 0, that's not very accurate. We don't know what it is. We can look in our table for this one. Control T, and you get 5, 0. That's the one that has the even multiplicity. So what we know about that is this is going to be the part where it's x minus 5 squared for part of it. What we want to do is either synthetic or long division. I think most people prefer the synthetic. You take your opposite sign, which is 5, and then take these things, the coefficients, 7, negative 71, 185, and negative 25. So you take your coefficients. Remember, if it didn't have an x term, for example, to put 0 right there. So just remember about the possible 0 missing term. We're using 5 because we got that from the calculator. And then we just do synthetic, which means add. You bring down this, 7 plus 0 is 7. Then you do 5 times 7 and put your answer here, which is 35. Now you're doing negative 71 plus 35, and that's negative 36. Then you want to take your negative 36 times 5, and you get negative 180. And then 185 minus 180 gives you 5. And 5 times 5 is 25. So you should get a 0 here if you did it right, because we knew that 5 worked. Okay, so you should get 0 for your remainder. Now, we also know that it was even or touched there, so we can do synthetic again with 5. Bring down your 7. 7 times 5 is 35. Negative 36 plus 35 is negative 1. And negative 1 times 5 is negative 5. So again, you get a 0 remainder. So now we're down to calling this 7x minus 1. We set that equal to 0. So 7x is 1, so you get 1/7. So this is the proper way to do it. I'll tell you a shortcut in a moment. Now, when you're doing your real zeros, it's going to be the 1/7 and 5, like that. For the factoring, For the factoring, you have to use your coefficient in front of everything, so don't forget that, because it won't work if you don't do that. You got to put a 7 there, and then you could put your x minus 5 squared and your x minus 1/7. So that's what it wants. Now, for those that don't like to go through this process, here's a little hint. Try 1/7 and 1/14, because those are multiples of 7. Try 1/5, possibly. See what decimal matches. Yeah. So basically, if you don't want to go through this process, find out what decimal that is by going to Analyze Graph, then go to 0. Trap it between here and here. You get 0.1428 something. And then just on your calculator screen, you do 1/14, that's 0.07. If you do 1/5, that's 0.2. If you do 1/7, you get the 1428, and so on. So it's usually 1 over your coefficient. I wouldn't always rely on that, but if you want to guess and check and then verify it works, you can do that. Any questions? Okay. Okay, now on this ordered pair, remember, if the numbers are bigger than 1, it's not on the unit circle. If the numbers are bigger than 1, it's not on the unit circle. So instead of just using y, we have to do y over r. So don't just put 2 here and then get it wrong. Don't just put -7 here and get it wrong. Our first step would be do your Pythagorean theorem. So -7 squared plus 2 squared. And by the way, on that, make sure you're doing parentheses around the -7 before you square it, because you should get 49 plus 4, which is 53. So your first step would be do your Pythagorean theorem. If you end up getting 1, then that means, oh, I was on the unit circle, so I did extra work. But if it's bigger than 1, it's not on the unit circle. Okay, so let's graph where we are at -7, 2. So that's the point, and then it goes down and touches the origin. So that means you're going left 7 and up 2. Now, I didn't finish this Pythagorean theorem part. I could call it c squared or I could call it r squared. It doesn't matter. This should be squared. But the point is that I've got to take the square root. So it's going to be the square root of 53. That doesn't simplify to 4 times anything, 9 times anything, 16 times anything. It's just that, right? Okay, so now that you have it drawn, your angle always touches the origin, so that's this angle. And so this is your y, which is the opposite, and this is your r, which is the hypotenuse. So you have 2 over square root of 53. Remember to rationalize, meaning you can't have square roots on bottom. So you multiply by square root of 53 over square root of 53. You get 2 square root of 53 over 53. That's your answer for your sine. For your cosine, you get negative 7 over square root of 53. And so then rationalize that. You get negative 7 square root of 53 over 53. Your next part, you're doing tangent, which is y over x. And so it's just 2 over negative 7, which is the same as negative 2/7. Then you want to do your cotangent. Remember, sometimes it has cosecant next, but in this case, cotangent. So you're doing 1 over tangent. So that's negative 7/2. So just flip your answer. Don't change the sign, because remember, cotangent and tangent and tangent and cotangent have to have the same positive or the same negative, the same sign. For secant, we've got 1 over cosine. So flip your original part. So you've got square root of 53 over 7. That's the easiest way to do it. If you'd rather take your other answer and split it, you can. It's just, this is when it's a little extra work, when you'd have to do your square root of 53 over square root of 53. Then you write it as negative 53 square root of 53 over, I'd say this is 7 times 53, and then just cancel. I don't even bother multiplying it, because if you do multiply it, it's going to count it wrong on your Math Excel unless you reduce it. So like, what I'm saying is 53 times 7 is 371. You would have had to say negative 53 divided by 371. Which is negative 1/7. And then you put your negative square root of 53 over 7 here. So it's really best if you just flip the original, if possible. Any questions? Because again, what some of y'all have been struggling with is simplifying square roots. Okay, for the cosecant, it's 1 over sine. So flip your original, so you get square root of 53 over 2, and you're done. Again, if you wanted to do the other one and do all the extra work, you can, but it's not really worth it. Any questions? Okay, number 20. They're telling you this function with the restriction x greater than 0 is 1 to 1. Find the inverse and check your answer. So the first thing we're going to do is rewrite this as y equal x squared minus 7 over 5x squared. So I basically just changed f of x to be y. The next step is you want to switch x and y. So you get x equal y squared minus 7 over 5y squared. There are steps on this one, so make sure you show work. Get rid of your denominator by multiplying by 5y squared. So we get 5xy squared equal y squared minus 7. So basically we multiplied by 5y squared for it to cancel. Now we have to move this y squared over. You're not multiplying by -7, it's just kind of there. And so then you're going to subtract y squared. So you've got, okay, we'll continue this one tomorrow.